All right, so we're going to actually start at the very beginning here, and of course, so explain the title of the course, which sounds silly, but in this course, that's somewhat important. All right, so the applied word is not very interesting. In some sense, we're going to apply combinatorics to a variety of situations. With the word combinatorics, if you break it down, it talks about study of combinations, and this has lots of flavors. We're going to study a variety of these flavors, but it's actually we're going to break it into two sort of main types of combinations we're going to do. So the first thing we're going to do is something called enumeration. This is where we'll start the course, be about the first half of the course. And you can make it sound kind of funny, but this is where we're going to learn to count. And sure, 1, 2, 3, 4, linearly counting like that, counting the number of fingers, that is one of these. That's the silliest one to mention. We're going to count much more complex situations. We're going to say, how many ways can you do the following? Or how many ways can these outcomes occur? Those sorts of questions. And these get very complex fairly easily, and this is a deep and difficult subject. It's going to seem like it's a very different subject, but we're also going to study not just combinations and counting them, we're also going to study combinations of items, of structures. We're going to look at how structures can be combined together. And this is going to be mostly graph theory. Okay, but we're going to touch on where this sort of subject interfaces with other subjects. For instance, I'm going to talk about how it has some geometric impacts. This is important if you're designing circuit boards or doing things in architecture or structures. Believe it or not, this simple little subject here can inform some restrictions about what you can actually do. Okay, so again, this will be the second half of the course, and enumeration will be the first half of the course. And we're going to start there, and we're going to lay down a few principles, which are some fairly silly examples to get started, and then we'll build on complexity. So we start enumeration. What I want to talk about here is something called, we have two principles. I'm going to start with something called the multiplication principle. Okay. And then the second one, which will probably be in the next video, will be the addition principle. I managed to spell principle right, I believe, right? P-A-L is a person, typically, or a leader of some sort. Principles, yeah, the L, hopefully is the right one. All right, so multiplication principle. All right, so what you do, let me say, let's number these so it's clear. So, multiplication principle. What you do is we're going to talk about enumerating outcomes. This word could change. You could be talking about events, or it could be much less sophisticated, just things, right? So it depends on context. We'll discuss more and more how important context is for doing these counting problems. All right, so the multiplication principle says if you first of all construct. I'll just pick one of these words. So I'm going to construct outcomes by breaking into steps. Okay. And then the multiplication principle says the total number of outcomes is the product of the number of options. So again, I guess you could use another word besides options, but do you pick one? So it's the product of the number of options in each step. And you have to be careful. There's a big if here. If, continuing my sentence, but I want to capitalize and really emphasize this if here. So it's the product of the number of options in each step if the number of options again, in each step. So if the number of options do not depend on the choice made in a previous step. Okay, we'll do some examples and this will get more and more clarity. This is a very intuitive principle. It's something you actually would typically do automatically. So maybe me describing it in this way actually makes it sound confusing, and that's okay. The important thing is actually to understand the principle, because you want to be able to not stop and second guess yourself if it feels like something might be wrong, or to check that you are making a mistake. So some critical verbiage here is if the number of options do not depend on the choice made in the previous step. It is not saying if the options do not depend on the choice made in the previous step. Believe it or not, the choices made in previous step might actually affect the collection of options left to you in subsequent steps. It's the number of options that is really important. Okay, so not the actual options, but the number of options. So if I don't have a lot of room for an example, so we'll do an example in the next video here. But basically, if we broke it into, like, say 3 steps, and we had a certain number of options, actually fit it here. We'll do a much more cleaner example that'll fit on the board nicely. If we had, say, 3 steps, step 1, 2, and 3, so I'm just talking about my steps here. If I had 10 options for the first step, 5 options for the next step, and 2 options for the last step, I would multiply this together, 10 times 5 times 2, and that would be 100 possible outcomes. Okay. All right, so we'll do some examples on the next video here of the multiplication principle. We'll do some ones where the options don't actually interact at all, and we'll do one where it is important to remember that's the number of options, not the actual options. So, all right, so I'll see you in the next video for that one.